self-built housing initiative, which has led to the advisory investment engagement with 7 housing finance companies in India. Mr. Syed has also facilitated more than 3 billion US dollar of IFSC's green building investment to developers, companies, and financial institutions across Asia. A trained architect and building sustainability expert, worked with Johnson Control in USA as an energy program manager before joining IFSC. I welcome you, sir, and uh, we we know that this session will be a very wonderful session where we will be discussing about the financing and green building and this decarbonization. So it's one of the important session we feel in the GAN program. So over to you, sir.
Thank you, Mangeshi, and good afternoon, everyone. I hope you can hear me clearly.
Yes, yes, sir. You're audible, sir.
Okay. And how much time do we have for this session?
This session is up to 5 o'clock, sir.
Okay. So, uh, what I'll do is I'll present, but I will encourage if anyone has any question anytime, please stop and ask. Please stop me and ask rather than wait till the end, because I feel it's best to discuss when the topic is hot. When we're talking, when I'm presenting, if you have a question, immediately ask and we'll dig deep into whatever aspect that you're interested in. So
So,
I've shared my screen.
so they'll be posting their questions in the chat section.
Okay, great, great. Yeah, please do that anytime. And I'll, as in when I see the question, or if you can just highlight whenever a question comes up, I'll pause and immediately try to address that. So, as Mangeshi had said, I work for International Finance Corporation, which is part of the World Bank Group. The World Bank, as you know, is a global entity. It's like United Nations. It's owned not by one country, but by about 180 governments, including Government of India. So, in a way, it is a government-owned entity, but shared across 180 governments. And the overall uh, perspective or overall target of the World Bank Group is to reduce poverty, increase shared prosperity, and within that we work in the private sector as well. Excuse me. So we work across a private and public sector. In the private sector, which is where I focus primarily on, the focus is on how can we help the local economies, the local businesses grow in a more sustainable manner. And buildings obviously is one of those sectors that we work on. So I'll dig deep more, but we are a non-profit entity. We are not trying to make revenue out of this. Our intent is to support uh, whatever initiatives that are ongoing, start new initiatives, catalyze through finance or through advisory support or through knowledge sharing, uh, in order to improve that sector, to grow that, to help grow that sector. So now the challenge that we are seeing, I'm sure all of you are very familiar that in India, especially with the increasing pace of urbanization, more and more people are moving to cities. Right now, I think the ratio stands at about 30%. 30% of the population in India is in the cities, but that's growing fast. And about 50% of the population is expected to be in the cities by 2030. Now, when people move to cities, they obviously need a place to live. They need a place to have their education, to work, to enjoy. We need more hospitals. Now, we're not saying that those should not be built. They should definitely be built. There is a strong social need, but we have an opportunity in India that so much new construction is yet to be built. What if we make this construction, this new construction, to be built in a more sustainable manner so that it does not cause a huge burden on the environment and also on the infrastructure? When I say infrastructure, I'm talking about the energy systems, the water systems, the waste, like the sewage system, for example. Air pollution is another issue, water pollution. I was just reading a number somewhere yesterday only, that if the air conditioning growth that's happening in India continues the way it is already happening over the last few years, in by 2030, we will need thrice the amount of energy that we are generating right now. So just imagine if we continue to air condition our buildings in the same manner, we'll have to increase the number of power plants, the number of energy sources by 3 times. Just imagine how where that would come from. It's very expensive, very difficult to actually build new power plants. And of course, it causes, if we are looking at fossil fuel, causes air pollution, greenhouse gas emissions, etc. So there is a way out. Design buildings better, so they need less air conditioning, they need less electrical energy, they need less water to be consumed, so that we can balance meeting our social needs, but in a more environmentally friendly way. The other aspect of climate change that we are looking at is resilience or adaptation. By designing green buildings, what we are doing is we are trying to reduce greenhouse gas emissions so that climate change doesn't happen as much. So we are mitigating. But we also know that climate has already started to change in many ways. Look at the floods in Chennai and Bangalore and Mumbai, and many other cities across India the last few years. They've been unusual. The weather patterns have been unusual. Like in the Himalayas, you've seen a lot of landslides happening, a lot of major flood events happening, rainfall events happening, which have caused major havoc, both livelihood damage as well as physical property damage. So, how do we deal with those changes that are already happening? We call that adaptation, climate adaptation. So in the building sector, this is a very new field. Not a lot of people are looking at adaptation in a very standardized, structured way. So we've tried to do that, and I'll talk briefly about that too. How can we quantify the possible impact to a building from various climate and natural disasters, and how can we reduce that? So just summarize, we're talking about two things. One is how can we make our buildings more efficient, and second, how can we make our buildings less risky to climate and natural disasters. So they both kind of go hand in hand. Now, the concept of green buildings has been around for a very long time. If you go in our history, our vernacular buildings, buildings that were built like 100 years ago, and even now, many of the buildings built in like rural areas, they are, you can in a way classify them as green because they don't use a lot of resources. They use natural, locally available materials. They are not air conditioned. They are naturally ventilated. They are naturally lit. They don't use as much equipment. But I'm talking about modern buildings now. If you look at modern buildings, while most architects, engineers, developers, corporations say that they are aware of the concept of green buildings, very few are actually building them. So our data says that only about 5% of the new construction in India is built to green standards, green certified standards, which means that 95% are not really caring about this, which is a problem. Because as I said earlier, our resources are limited, our water supplies are limited, our energy supplies are limited, and we have to take care of those by designing better buildings. Now, if you ask an owner, why are you building so few green buildings? Or let's say ask those 5% first. Why are you building those green buildings? These are the major reasons given by building owners. The first is there is a requirement from the tenant or the buyer, like the major IT companies, MNCs. let's say if Microsoft is building their office or renting an office in Bangalore, they will have a requirement that this office should meet a minimum standard. And most often, green building certification is one of those requirements. So this might come up as a requirement, a demand. It could also come up as a requirement by the investors. Now, many global investors, including development financial institutions like my own IFC, is requiring that all our investments should be used for green buildings. All real estate investments should not be used for brown assets. They should be used for green assets. Then there are some developers or building owners who are targeting the incentives that are coming from local institutions. Many of you may be aware there are several states and municipalities across India that provide some kind of an incentive for green buildings. Like just yesterday, Rajasthan government came out with a new policy for green buildings where they are providing additional building area ratio, or you can say additional floor area will be allowed to be built by projects that have a green certification, including the ones that we provide called EDGE. So if somebody is wanting to build more floor area, or they want a lower property tax, or they want some other kind of incentive, they might go for green buildings. The last reason that we often hear is self-awareness. Now, this is probably the least, in terms of all, if I compare it to the other reasons, that this is the least proclaimed reason, which is there is a company which says, we strongly believe in saving environment. We think this is very good for us. So regardless whether there is incentive or not, whether the investors are demanding, we will build more efficient, more green buildings. So there are a few companies that do that, but it's not the norm. Hopefully that will change over time as more and more developers, more and more companies start to become aware of the importance and the business case of building green buildings. Now let's look at why the 95% who's not building green, why are they not building green? The first reason is they're not even sure what green building means. What is green? It's an abstract term. It's like asking somebody, are you healthy? According to which metric? Are you talking about my blood pressure, about my blood sugar, about my BMI, or what is the criteria for health? Similarly, the criteria for green has been fuzzy, has been not very well defined in many parts of the sector. So we'll address this in more detail. Secondly, some people say, oh, it's too costly. Now, there are myths around it. Some people say, oh, if you build green, your capital cost will go up by 20, 30, 40%. Now, that may be possible. And I know buildings that where they've spent that much money. But if you design it well, if you start implementation in early stages of the project, it is possible to build zero carbon buildings, highly efficient buildings at even zero cost, zero additional cost. I'll give one example. Maybe I'll mention it right now, but I'll mention more about later. The biggest portfolio of net zero energy or net zero carbon buildings in India is owned by Infosys, the IT company. Now, Infosys has multiple campuses around India. They have fine-tuned this art of designing highly efficient buildings to the extent that now their capital cost is zero. The cost of designing buildings before they started adopting green has not changed over time. It's still the same cost. How are they able to manage it? We'll talk about that in a bit. But it has been proven not just in one or two buildings, but across large portfolios. And Infosys, for example, is happy to share information about it. If you just reach out to them, they'll be able to share a lot of data on technologies and empirical data as well to prove their point. Number three, people say it's too complex. Well, it can be complex. Let's go back to the analogy of health. If you want to lead a healthy lifestyle, you can build a very complex plan requiring huge amounts of cost and effort and data analysis in order for you to remain healthy. Or you can just focus on the basics and do it well. Focus on good diet, exercise, maybe good sleep, and in most cases, this will ensure good health. Similarly, for buildings as well, it doesn't have to be very complex. The basic concepts of a green building are simple, and we'll talk about some of those concepts in a bit. If you just follow those basic concepts, it's very easy to build a green building that is low carbon, has low operating cost, and is comfortable for their occupants. Number five reason people say is they ask, "What's in it for me? Why should I do it?" Now, that's a that's a very broad-based question, but typically they're looking for financial payback. Most companies say, if I invest this much time and effort in making my building more efficient, what do I get out of it? Now, the answer depends on whether what kind of a building is it. Will the investor, will the owner continue to own the building, or will they build it and sell it out? So the answer will vary depending on what the situation is. But I can tell you from experience, from our last 10 years of experience in doing this in India, is that the average payback for a developer to build green buildings is between 1 and 3 years. When I say payback, I really am looking at what is the capex and what is the opex saving. So in these buildings, the opex savings, the operational cost savings that you have over the first 2 to 3 years will repay any additional cost that you've had in making that building green in the first place. So, and this, we have a lot of data to show that as well. So it's again lack of the data, lack of the understanding of this data, which causes a lot of companies to hesitate in going for green buildings. And if you have any questions, please do jump in. And also, if your experience is different from what I'm mentioning, if you feel there is some other reason or you have insights, please do share anytime. Let's make it as interactive as possible. Now, let's look at the first reason. People say, oh, we don't really know what green means. So let's look at the fundamental definition of green building. Green building, according to us, is a building that optimizes use of natural resources, such as energy, such as water, such as materials. But at the same time, it is providing or fulfilling the needs of the occupant. The needs of the occupant, they need space, they need comfort, they need to have their appliances, the equipment. They should be able to operate and do their work in the building. So if all of these requirements are met and we do it in a more efficient way, we call that a green building. Now, recently, we've also started to include adaptation, climate adaptation or climate resilience as part of this definition, which really means that you're not just designing these buildings to be highly efficient, but you're also designing these buildings so that they last long. If a flood happens in the city, it doesn't get damaged. If there is an earthquake, if there is excessive heat, it doesn't cause major disruption in your building. Now, there are different levels of green, you can say. There is the mandatory level, which is the law, which is the requirement, the code requirement. Now, if you know, there is an NBC, National Building Code in India, which has certain requirements, and that code is being reviewed right now or revised right now. And there is also an energy efficiency code called ECBC, which again is being revised and upgraded now. It's called ECSBC now. If you look at those requirements, they talk about mandatory things that every building above a specific size has to include in the project design. Again, the focus is mandatory and minimal requirements. So they talk about minimum air conditioning efficiency, or the minimum uh, uh, kind of specification of the glass or the lighting system, etc. So there are some minimum requirements. And if you look at the code, actually it's a fairly robust code. It can provide good amount of saving. Unfortunately, in India, we've had very low enforcement so far. It's been 17 years since that code has been in place in different versions, but only about 2,000 buildings have really complied, which is not a very good picture because it's representing a very, very tiny portion of the overall market, overall new construction. So, one way to improve our buildings is to make this enforcement more robust. Make sure that every single municipality, every single state has a way to check compliance with the energy code, without which the building owner does not get a permit to build. If we can maintain that, if we can be disciplined about that, then a large part of that, this problem will go away because every building will have a minimum level of efficiency. Then there are great examples of what has been done in a few countries. Like I worked in Indonesia and China before. In those countries, in some jurisdictions, they don't give you the building permit, the construction permit, if you don't follow the law. And if during the construction you're not following the code, they will come and seal your building. They will put a big banner outside your site saying this construction, this project has been stopped because they were not complying with the building code. We need something that's as strong, as robust as that in India. Right now, it's fairly lenient kind of enforcement, if at all. The next level of green is what we can say are standards, corporate and industry standards that some people have adopted. Usually, these are voluntary. Uh, these are standards which come from in industry association, such as ISHRE in India, and there might be other associations related to, let's say, uh, fire safety or water efficiency, or there might be sector specific standards like the Warehousing Association of India has come up with their own standard and guidelines for warehouses, and there might be others as well. In most cases, these are guidelines, these are recommendations. They are not necessarily being adopted. There might be some companies which can come in and say, okay, this standard makes sense for me, so I'll adopt it for all my projects. But at a national or at a government level, this is not being enforced. The third level, which we'll talk more about, is the voluntary green rating systems, or we can call it the green building certification systems. Now, if you look at the existing systems in India, there is the local IGBC system, the GRIHA system. There is also a GEM system that has come up recently. If you look at the international systems that are present in India too, it includes LEED, which is probably one of the first certification systems globally, and EDGE, which comes from my institution, from IFC World Bank Group, which has also been around for the last 10 years or so. So there are multiple systems that are out there. And I can briefly talk about the key differences and what makes sense where. Uh, so let's start with the oldest one, LEED. LEED is an international system, as I said, globally adopted, globally recognized, uh, but it was not really designed for India. It was designed in the US. There have been some tweaks to make it more international, but still it is very West centric, you can say. Uh, there are numerous lead projects in India, which is a great thing. And a lot of international clients require their projects to meet the lead standard. But the cost of meeting LEED can be a little high. The effort may require some time as well. I've worked on projects, LEED projects in my previous job, which took like 1 year to get the project certified. So, because of those issues, outside the MNC sector, the adoption in India has been a bit low. Let's look at the next one, which is IGBC, which is a locally customized version of LEED, you can say. So they've tried to take the LEED standard and tweak it so that it becomes more locally adapted, which is a great thing. They've done that. But unfortunately, they've not got international acceptance because of the verification standards that most international investors require. They are they are not meeting those international criteria at this time. Hopefully, they will get there. IGBC has been around for the longest time in India, and they've got the highest certified floor area in India as well. Now, what the reason we came in, Edge and IFC came in and created a new system globally, is because we were trying to bridge the gap. We want buildings in India of all kinds, all sorts, to meet green standards and yet be internationally recognized and be eligible for climate finance if needed. So we're trying to have a localized system, very customized for India, yet it is attuned to international finance standards, globally recognized, and very quantified, because investors don't really care about number of points you've generated in a scoring system like LEED and IGBC does. They're concerned about the performance. How much energy is this building going to save? How much greenhouse gas emissions is this going to save, etc. So with that in mind, we have created Edge, and I'll go into more details of Edge later. So in summary, what I'm trying to say is all these rating systems are like different brands of cars. Depending on your need, depending on how you want to run it, where you want to drive, how many people, what is your budget, you can choose the system. They all have their good points and they all have their kind of weaknesses as well. All right, let's go beyond. Now, the cost. As I said earlier, it's actually possible to reduce the cost significantly. We have seen that typically the incremental cost of green buildings that are going for Edge is less than 3%. This is additional cost beyond their original budget, and they can recover typically within 2 years. Infosys example that I mentioned is there for you to see. They've almost perfected this art. They've been doing this over and over again. Now, how do they get there? How do they manage to reduce their cost so much? The chart that you see on the right, the inverted pyramid, is the key. We call this hierarchy of design decision making, which says that if you have to reduce energy consumption, let's focus on energy at this time. Same applies to water as well. If you have to reduce energy, the first thing is to reduce the need for energy appliances, energy using appliances. Energy using appliances means air conditioning, electrical lamps, uh, electrical fans for ventilation, etc. So if you can make your building, the building envelope, the building facade, in such a way that it does not allow a lot of heat to come inside, it does not allow a lot of it allows some natural light to come in, but not so much that it becomes glare. It allows some natural wind to blow through when the temperature outside is good. Then your dependence on AC, on your electric lighting, on your ventilation systems can be drastically reduced. This is probably the most important way of reducing cost in a green building. Now, the second aspect is now that if you've reduced the need for air conditioning, now your air conditioning system, rather than let's say being 50 tons can be 35 tons or 30 tons. So you're installing a much smaller air conditioning system. So your capital cost also goes down because you don't need that much of a chiller now. But maybe you can now go for a higher efficiency chiller. So you're installing a smaller chiller. Let's make it as highly efficient as possible. Let's make it, let's say, a water cooled chiller. Maybe go for like a 6 COP or even higher efficiency if possible, so that you're able to provide more cooling using less energy. Same goes for lighting. Buy the most efficient LED lamps, for example, so that your uh, consumption for every lumens of light that comes out of the lamp, you're providing less and less wattage to that lamp. And now you're getting highly efficient LED lamps in the market. Uh, Related to that is also the controls. In Indian buildings, commercial buildings especially, you see a lot of wastage after hours. If you just go out and look at any office buildings after, let's say, 7 o'clock or 8 o'clock, when there's hardly anybody in the building, you'll probably see most of their lights are still on, most of their air conditioning is still on. So that is a sheer wastage. And it's so easy to reduce that just by installing some timer control, occupancy control, or some other kind of a building management system that automatically shuts down these things after they're not being used. So that's controls. Now, the third aspect, now you've installed all these efficient systems, highly efficient cooling, highly efficient ventilation, lighting, etc. How do you run these systems? How do you power these systems? Usually we do it from the regular grid electricity. But what if we source this from a renewable manner? The best is on-site. Off-site is also good, but we know that there's a lot of transmission wastage or losses. If you're getting your green power from your regular grid, by the time it comes to you, it's probably lost 30-40% of the energy that was generated. So that is also a wastage. Best is if you have space, if it's feasible, to provide renewable on site. And now there are numerous ways to provide that. Solar cost of solar has come down drastically. Payback is really good. And now there are new technologies like building integrated PV panels, like even glass panels that are now coming out, which look like glass, but they also have these PV panels built in. So it generates some electricity as well. Now, the last bit, after you've done all the renewable energy, wherever you can, on site or off site, you might still be left with some residual energy that you still need to get from your grid. For that, the last option is offsets. Now, this is slightly controversial. Some people say this is not really green because when you're buying carbon offsets, you're basically passing the buck to somebody else. You have money, so you're polluting, and you give the money to somebody else. So if somebody is built, let's say, planted a huge forest, or somebody has built a wind-powered energy farm, they've built some carbon credits which you are buying. Basically, you're taking the ownership of those carbon savings in return for some money that you give to that carbon farm or your wind farm, etc. So that is still allowed in most systems, but my hunch is that will become more stringent and might even go away after a few years. So we'll have to rely more on renewable power to make our buildings zero carbon. But the good news is the cost of renewable power has really drastically fallen over the last few years. In many cases, it is at the same price as regular power. Please jump in if you have any questions anytime. I'll take maybe 1 minute more to talk about the passive design measures. One example, which you can also look around. So Again, if you go to any major city in India, look at the large commercial office buildings. You will probably see that most of these buildings are now built of an entire glass facade. The entire elevation is glass, which appears to be like the new trend, the new vocabulary of modern office buildings. If you ask the architect and the engineer and the owner, why did you design a full glass building? They will say, oh, because we want the light, we want the visibility, we want the transparency, the whole building looks lighter. That's great in theory, but if you go into any of those buildings, what's really happening in a tropical climate like India, with these glass buildings, even if they are highly efficient glass, you get a lot of heat and you get a lot of light. So when you get a lot of heat inside, because glass is not as insulating as a wall, you get a lot of heat. Now you have to remove the heat. So your air conditioning system is being oversized. You need to design a bigger chiller. So your cost of designing the glass goes up. The cost of installing this air conditioner goes up. And you wanted light. But because this building has so much glass, you're getting excessive light, excessive glare. So most people will bring down the curtains or the blinds. And if you look at any office building of that sort, you will probably see that most of the windows have their blinds down. That means they're not getting the natural light that they wanted or the architect wanted. So now the inside of the building is dark. So now you have to turn on the lighting, and you're spending more money on powering the lamps during the day when there's so much natural light available. So this is an opposite of a win-win situation, a loss-loss situation. You have spent too much on your capital cost, and now you're spending too much on your operational cost as well. So it makes a lot of sense to optimize your glass in a building, just enough to get enough natural light and ventilation, but not too much. And therefore, you're able to downsize your mechanical system, your lighting system, your cooling system, etc. So those are the smart decisions that can help companies like Infosys reduce their capital cost and bring it down to almost zero. Now, let's take one example. Okay, there's a question. Puneet, let me just try to read your question. So Puneet says, from my understanding, the first one, what's green, is the most significant factor, as installation of solar panel has seen sudden growth, especially in Maharashtra because of high bills. So people are inclined towards go green. So will awareness plus fear of losing money can be the key? Absolutely. Absolutely. If you have to make a business case, we have to look at what will be the financial implications, and not just now, in the future, because the cost of electricity, the tariff is going up. If you're paying 12 rupees a unit now, you might end up paying 20 rupees in about 5 years. And therefore, it becomes very important that you're paying attention to the cost benefit analysis as well. And you ask, was similar to what solar panel, what else can you use for green buildings? So we'll talk a little bit about some of the ideas. Solar panel, I feel, should be the last resort. You should not start with the solar panel. You should start by optimizing the building envelope, the size of glass, the kind of shading that you provide on the glass. Then you go to the interior systems, the kind of fans, the kind of air conditioning systems, the kind of lighting, the kind of controls. If you're looking at a hotel or a house, looking at the hot water systems, look at things like reflective paint on the terrace. These are all lower cost items that can significantly cut down your energy bills. Raghavendra is asking, may I know the usage of BLDC fans really contribute to energy efficiency? Yes, they do. So in a typical house, let's take your own house, for example, you might have like 4 or 5 ceiling fans. Typical wattage of the non-BLDC fans is about 75. So 75 times 5 times On an average, the fan would be running, let's say, 15 hours a day. There might be some fans that run 24 hours a day. Uh, that's a lot of wattage, watt hours. So it can add up. Even though one fan by itself may not consume a lot, but if you just add up all of that, BLDC fans are almost half the wattage. The average wattage of a BLDC fan would be like 35, 40. So they can almost cut down your cooling, your fan energy by 50%. Great questions. Thanks for asking. So what I did for today is just picked up one regular building, not a very high profile building, not a very kind of a big signature office building. It's a small, moderate sized office building in Kochi. Now, what can be done to make this building a net zero energy, completely decarbonize at minimal cost? There are different approaches to it. Like we were talking about this hierarchy of design decision making. That's one. Or you can just say install solar PV. So scenario one is just put solar PV, a big enough solar PV to meet all its needs, all its energy needs. And you can call it a highly efficient building. But the cost of doing that is very high. For this specific building, I've calculated the cost without solar PV would be 4.2 crores. If you add solar PV, which would cost roughly about 35 lakhs, it becomes 4.55 crores. And the annual operating cost is 7.1 lakhs. Now, in scenario two, we do a more strategic, more intelligent design optimization using that same hierarchy that we talked about. We can look at different options and first optimize the windows, optimize the glass, downsize the chiller, downsize the lighting control, and then provide solar PV. Our capital cost comes down to 28 lakhs. And our operational cost also comes down significantly. So you can see that your the two approaches can have very different output. So that's why we are recommending that you use this simple hierarchy of design decision making. It does not take a huge amount of time. And the edge tool that I'll be introducing shortly will help you in that. So, in order to answer the question, it's too complex. Uh, we say that there are these 4 or 5 simple measures that would help you get 20 to 30% saving without significantly increasing the cost. You don't necessarily have to go to like extreme cutting edge technology, which typically is higher cost initially. Uh, you can make do with simple technologies that are already available in the market. So glass, the right kind of glass sizing, the right kind of air conditioner efficiency. If you're in a hospital or an office or a retail, heat recovery. If you're in a hotel or hospital or housing, domestic hot water system using solar power, solar water heating, or heat pumps, and a few other things. So if you go to Edge app, you will get a quick analysis of what this entails. How do you actually meet these requirements? What's the impact of selecting any of those measures? And I'll give a quick glimpse of this subsequently. Now, the fourth challenge was it's not required. Why should I build green? Now, most global investors are requiring green. If you look at any major investor like HSBC, Hong Kong Shanghai Bank, if you look at Standard Chartered, if you look at BII from UK, if you look at many other investors, uh, the Canadian Pension Fund, they're all requiring that you meet some green standards. In fact, some of the investors are saying that if we are investing in a company that's not focusing on green, we might pull back our investment or make changes in the board, in the directors, if they're not paying attention. Governments are also paying attention. The example in the middle, which is from UK, they've told the UK government that if you do not have a carbon reduction plan, then you will not get government contracts. And lastly, the policies are also changing. So the tariffs are changing for water, for energy, etc. If there are professionals, architects, engineers in this webinar, let me point out another change that I just saw. Uh, this is from UK. This just came out last week. I saw it last week. The UK government, there was a court case in the UK government where the building owner sued the architects because this building was getting excessively high energy bills because the architect did not pay and engineers did not pay enough attention to energy efficiency in the building. So they are being sued because this is not energy efficient. So that's a trend that I expect will grow, and probably in India as well. So we better be aware, if you're an architect or engineer or a developer, better be aware that this is the future that we are going to have. So better be prepared for it now. So what's in it for me? We see that if you're not paying attention to any of these things, then the future of your business, the future of your project is in doubt. It may become obsolete. Your investors may not want to come. Your tenants may not want to prefer those buildings. The buyers, the value, the asset value may go down. So it becomes less desirable of a property. And eventually it might become a stranded asset, meaning nobody is renting that place and you're left with a huge liability. Now, in order to overcome all of these issues, IFC and the World Bank has launched this program about 10 years ago called the Green Building Market Transformation Program, where we are providing investments to green properties directly as well. So let's say if there is a large affordable housing developer who says, I will build all my apartments to meet a minimum green standard, we may invest directly with that investor, with that developer, to support that initiative. The other way we invest is through local banks. So if there is a bank that is planning to start a construction loan for developers that is meant for green properties, we can invest with that bank so that they can start this project. Similarly, if the bank is planning to start a home loan product that is meant for green properties, we can do that. In fact, we have already done it with HDFC and a few other banks, and we're planning to do a few more. So that's one way of kind of driving the demand and supply it also. The other way we can get involved is policy making if there is a need. Where we, like in India, for example, we are working with Ministry of Finance on the climate taxonomy, and we are also working with some state governments on their incentive policies for buildings. At the heart of all our work is the EDGE certification, which we'll spend a few more minutes on now. Now, EDGE is one of the three tools that we've developed in the urban space. EDGE is focusing on the individual building elements, on how can these buildings be built in a more green and sustainable manner, and how do you quantify the efficiency of these buildings even before they're built. The second tool is called Apex, which is working with cities, municipalities in most cases, where we can support these cities in creating climate projects. Like we're working with Chennai, and we've identified few climate opportunities. There are things such as electrification of their buses, uh, solar panels on their government buildings, or higher efficiency retrofits of some of their larger private institutional buildings, and so on and so forth. So we can come up with these city level engagements as well. The last bit is the Building Resilience Index, which looks at quantifying the climate resilience of projects. Again, this can be done before they build, or it can be done afterwards as well. I'll talk a little bit about that in one of the subsequent slides. And we've put in a lot of investments to back it up. This is our investment growth over the last few years. Cumulatively, we've invested about $2 billion in India in the green building space. And we work with many of the other investors that are listed below so that they can utilize the Edge platform, the Edge criteria for their own green building investments too. Uh, Actually, we have a separate session tomorrow where we go into more detail, but we do three different kinds of investments. It could be loans, it could be equity, it could be capital market engagement. And we work across the market with several local banks and other investors as well. I'll skip this slide and maybe this one as well. And let's go straight into Edge. So green building. Now we've talked a lot about green building, but what is the quantifiable criteria? It is that a building has to be at least 20% better than the local benchmark, the local baseline. And secondly, it has to be verified by a certifier, an independent third party verifier, and they should be able to report the actual savings, actual kilowatt hours of energy saved, actual tons of carbon emissions saved, etc. And that then only it will be called as a green building. This is a global criteria or, by all major climate investors. So we've taken the same criteria and come up with the Edge system, where the software that we have developed will help you meet that minimum criteria of 20% improvement above the local baseline on energy, on water, and on materials. And then it goes through an audit process and you get the certificate. Let's take a question that's come in. Abhiram is asking, how is the Edge green building criteria different from other green building standards? What are the additional things focused on? And I think you have a similar criteria, a similar question by Harshal. What are the criteria IFC looks into for allocation of funds? Do they fund recycling infrastructure or green material production units? Okay, so let me address the benchmark of the criteria. So if you're familiar with the other green rating system, they are working across multiple categories: transportation, landscaping, indoor air quality, energy, water, etc. We've focused on three things only, three aspects: energy, water, and material. And because we are looking at things that are hardwired into the building, that are installed in the building, they're not really operational focused as much as design focused. Because once a building is built, it's very hard to actually change things in the design. One example or analogy I'll give you: when you go buy a car, you ask the manufacturer or the seller, what is the mileage that this car gives? Kitna kilometer deti hai? So that is the analogy we are using. When somebody is going to buy or build or rent a building, they should be able to get an estimate of how much energy would this building consume, how much water would this consume, and base a decision on that. So our criteria is, if you reduce 20% on your energy consumption as compared to what the local baseline is, 20% water, and 20% embodied carbon of construction material. So there are no point system. You cannot trade off between these three categories. All three criteria have to be met before a building can be certified. We can talk more about the criteria for IFC funding maybe tomorrow, because we'll be talking about finance. But generally, I'm touching the major points here. So in order to make this knowledge freely available, what we've done is put it all on a free website, edgebuildings.com. So any of you can go in right now or anytime later, log in for free and start using it. Do as many assessments as you like. There is no charge to it. And it already has the data for about 50 cities in India and for 8 building types. So you can work across any of those in India. This is what it looks like. Once you enter the software, the first thing it asks is the building details. You tell, let's say, if you're doing a hospital in Nagpur, and this hospital is, let's say, a general hospital, not a multi-specialty hospital. So you tell these three things, plus you give the area, the floor area, how many floors does it have, uh, and a few other things that it'll ask. Based on that, it will dig into its database. The software will figure out how are general hospitals in the Nagpur region being built and specified nowadays. What kind of wall materials are they using? What kind of energy system they're using? What kind of water systems they're using? And what are the typical operational behavior that they have? What temperature setting do they have for their air conditioning system? What is the 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 amount of the number of hours that the ACs run? What are the water systems like? And even what are the tariffs, energy, water, diesel, etc. tariffs that you have? It already has the data. It will take all of the data, apply to your project, do a quick simulation for 1 year, and say if your building, this hospital building, is designed with the current specifications prevalent for hospitals in Nagpur, this is how much energy it will consume. And that becomes our baseline. So if you see there are two bars on the right hand. There is this baseline bar that the software will evaluate and tell you which is the starting point of our analysis. And it also tells you where this energy is expected to go in kilowatt hours per square meter per year. So you know where the biggest consumer is. And once you start assessing by selecting some of these measures on the left, this bar on the right will start to change. It is representing your actual building, your improved building design. So if you say, I will have a better, let's say, air conditioning system, if you select from the menu on the left, there are multiple things on the menu. You don't see all of them in this screenshot. It will show the impact on your energy saving. And at the top, it will also show impact on your utility cost, on your electricity bills. How much does having a higher efficiency air conditioner, or a reflective paint on the roof, or your chhajjas on the window, what is the impact on capex? What is the impact on opex? You'll see that in real time for every single change. And this is for energy. Then we follow the same criteria for water and materials as well. So you have a baseline and you have a series of measures that you adopt. And as long as the performance of that metric is reduced by at least 20%, you are on the right track. So just to answer the question that was asked, what is the criteria? The criteria is performance, 20% reduction in energy, water, material. We don't care how you got that reduction. You do it through better insulation, you do it through better air conditioning system, you do it through solar power on site. All options are open. The software will give you the capex impact of your decision. And that hierarchy that we mentioned, we believe is the best way to reduce your capex. But you can do it any way you want. So there is a lot of flexibility in the technical requirements. Now, as you're doing this assessment, the software at the top will give you all this information in real time. What is the saving? What is the capital cost, incremental cost, energy savings, GHG emission. If you want to do carbon reporting, this becomes an important, this becomes an important way to track your carbon emission savings as well. So in India, as I said, we launched this roughly about 10 years ago, and we've done projects of all sorts. It took some years for the market to adopt it, but over the last few years, the numbers have been increasing drastically, and we are close to 120 million square feet of floor space that's already certified, and almost 150 million more floor space is in the process of getting certified now. One example of such a project, Tata Intellian IT Park. This is an IT park in Chennai, an old existing building and they retrofitted the whole building to meet the zero carbon standards. Zero carbon standards means they've cut down on their energy efficiency by at least 40%, and then all the remaining energy is being supplied by renewable sources. So it's a combination of energy efficiency and renewable energy. And this became the largest green or zero carbon certified property globally when it was certified. And the most interesting piece is it was not a new project, it was a retrofit. So if a retrofit can manage to do it, it is certainly possible for new projects to do it as well. And there are examples of new projects that have met very high standards. If you go to our website, edgebuildings.com, and you look at project studies, you'll see numerous examples of such projects, including some zero carbon projects like this lab in Ahmedabad. We've got one project in Jhansi, a library building, which just got certified as zero carbon as well. Now, one area where we felt that nobody was paying attention to was small individual homes, like a house that's being built in, let's say, a small town. Uh, Nagpur certainly has a lot of those. Bhopal, Indore, Coimbatore. If you go to these places, majority of the housing is still owner-built houses, not apartments. So how can we tackle this segment of the market and make it green as well? So we've come up with a new approach. We've piloted with 5 or 7 housing finance companies and created a new approach towards its certification for them. This is done through housing finance companies. So if you go to one of these companies, take a green home loan, they will provide the loan at a slightly discounted rate, plus provide technical guidance on how to actually build the house green. And they will come regularly while the house is being constructed and make sure all the requirements are being followed. So this is just been launched, and hopefully this will become available across the market very soon. This is one of those first few homeowners that got certified using Awas Housing Finance's investments. Now let's talk about resilience. We have 10 more minutes left. Resilience. Now, climate resilience, as I said, is a very new space. Resilience against what? There are different kinds of disasters that a building can face. There could be wind-related disasters, such as a cyclone, such as a storm. There could be water-related disasters, such as flooding. That flooding could be happening from the river, from the sea, tsunami. There could be fire-related things, a local fire or a wildfire, a forest fire. And there could be geoseismic things, which include things like landslide, earthquake, volcanic eruptions. And now there is one more risk that's not listed here, which is heat risk, heat stress. Like in last summer, when the temperatures went really, really high in some cities, we found that some of the homes inside were much hotter than the outside air temperature. So that means if they're sitting outside in the shade, they would be much more comfortable than inside sitting their houses. So heat stress has become a major problem. And if it goes beyond 50 degrees temperature, then it starts to kill people. It can kill people even before that. But beyond that, the rate of mortality really goes up, especially among the elderly and the sick. So it is a risk. And so far, it's been very difficult to actually quantify that. We've come up with this system, and the website is there, resilienceindex.org. Again, like Edge, this website is completely free of charge. Anybody can log in and start to use it. The way it functions is once you enter your details, it will firstly analyze the risk. What kind of risk is there? So if you look at these 3 categories, first goes be risk identification based on the site. So if you're sitting in, let's say where our office is in Mumbai, in BKC, BKC is close to the river, not too far from the sea. There is definitely a risk of flooding. There is definitely a risk of hurricanes. There might be a risk of uh, earthquakes as well. So, depending on the site, the software will first tell you what are the risks that are applicable to this site. The second level of assessment would be on the building design. So for our building, we will say, okay, it's a 20-story building, which has got so and so structural system. It has got such an electrical system. Yeah, the basement has a transformer, and there is no protection from water outside. And we'll put in some basic details of the building, and based on that, it will tell you what will happen if any such disaster happen. The applicable disasters, which in this case of BKC was flooding, earthquake, hurricanes. Based on the current building design, how much possible is it for our building to be damaged when these disasters happen? It will do a calculation and give you result in terms of probable maximum loss. If you see these percentages in this tile on the right, probable maximum loss means how much would it take to replace things that are damaged in the disaster. So if your windows get broken, there is a cost to replace them. If your transformer gets flooded, there's a cost to replace that, and so on and so forth. So it looks at the percentage replacement cost. If it's uh, less than 15%, then it's called A8. AA rating is basically incorporating global best practices. And it's very hard to get A because global best practices are usually fairly stringent and sometimes may have a cost associated with it as well. Then the second level could be the local best practices. And then the third level could be code compliance. And the last level is it is not resilient at all. So this will give you an estimate of how resilient my building is. The plus sign on the outside tells you the, the level of operational continuity. So if it is a plus, that means you can continue to operate the building. Because there might be instances where your building is not physically damaged, but your power supply is cut off, your transport is cut off, your electrical, your water systems are affected. So if you're a hospital, you cannot operate because you don't have power, you don't have water. The patients cannot come to your building. So that is operational continuity. It looks at that aspect as well. And if you're taking care of that, then you get a plus as well. So it could be A plus or double A plus, etc. So we are launching this system. We have already launched it. We are piloting this with a few key developers across India right now. Now, for really large portfolios, we can combine the two. We can combine our advisory offering and our financing through an integrated program like we're doing with Brookfield REIT in India. Now, my last slide is what exactly do we need for professionals to know? What are the key skills that if you are a professional, if you are in this industry, that in order to be future ready, we believe you should know. First is how do you optimize through analysis? If you're in the design industry, design and construction industry, how do you design better buildings so you don't spend too much and yet you get a very efficient building? Second is what are the key metrics that people are looking at? People as in your investors, your building owners, your building occupants, the government, regulators, what are they looking at? They're looking at capital cost, operational cost, which is traditional, but now they're also looking at carbon emissions. They're looking at greenhouse gas savings. They're looking at climate resilience. And thirdly, very importantly for everyone, how do we communicate and convince people? Because I feel that has been the biggest barrier, that we've not been able to communicate the strong business case for green buildings to our key stakeholders, developers, building owners, etc. So if all three skills are there, then the path towards decarbonization can be smoothened to a large extent. So that's my presentation. I'll stop here and happy to take any questions if there are any.
Any questions? Anyone? Any participant? Those who are in offline and online mode. So there is one question has come.
Okay, Raghavendra is asking, are there any important practices which you would suggest as measures to be followed in retrofitting? Yeah, for retrofitting, because you cannot replace a lot of things that are already in there. The first task I would suggest is look at the existing life of mechanical and electrical systems because they have an expiry date. So, like chillers, typically chillers become redundant and obsolete in like 5, 6 years. Uh, if it's beyond that point, then maybe it's the right time to replace those chillers. Similarly, lighting. If you have got old lighting systems installed, look at replacement of lighting. Then the second aspect would be controls. If your building doesn't have controls to switch off lighting, air conditioning, ventilation when it's not needed, those would be a simple add-on. The third aspect would be solar, renewable. Wherever possible, add renewable power to run those systems. Those would be my first three uh, choices, but again, it depends on case to case. The first thing that should be done is an audit of the building, figure out what are the specifications, what kind of systems are already in place, what needs to be added before that decision can be taken.
Any other question?
And you can note down my details as well in case you have any question later. We're happy to answer them separately as well.
Okay.
All right. Thank you so much.
Thank
It
you,
was a
sir.
pleasure presenting. Back to you, Mangeshji.
Thank you, sir, for a very enlightening lecture, and I found it very, very useful. And on behalf of the organizing committee, I thank you, sir, and I thank for the IFC as well. Thank you, sir. So
Thank
with
you.
this,
Have a good.
we have completed all 5 sessions of today's GAN program. So we'll be meeting tomorrow at same 9 o'clock. Thank you all.